And we're live. I'm Danny, the CEO of bld.ai, and I'm here with Farhan Khan, who is a senior lecturer near here at UTEM in Malaysia. So we're meeting here in Malaysia, but in Forest City, which is right across Singapore. So in the background there, we see Jurong Port. That's the most industrial part of Singapore. And we're on the Malaysian side in Forest City at Network School, where this was a failed real estate project years ago that is now being reborn and restarted with Balaji from Network School. But we're here to talk about you, Farhan. I know you've had a career that has touched both on hardware and on AI. You've taught many students, but you've also done work for the enterprise with big corporations, with the government of Singapore, with HP, etc. Start with who you are. Where do you come from and where you've studied, and etc.
I was born in a small village near the Indus River. My village is called Maneri Payan. I had a very humble beginning. I was the first in my family to get a university degree, but I liked to study. I didn't have a good environment. I was interested in reading very much. We had goats and we have a hilly area. I used to go to the hilly area with my goats and so that's how I started.
So they would eat, you would read, and they provide you milk.
And sometimes they would read and I would eat. So that was a joke by one of my teacher. But luckily I got good marks in my high school and went to university. I was interested in engineering. As a kid, I used to play with electronic devices at home. I caused many power breakdowns and also got electric shocks. And during the university, I got interested in computer science, especially at that time in the networks and the kernel programming. So my first love is Linux. The university I graduated from was called UET, University of Engineering and Technology. It was in Peshawar. Peshawar is our provincial capital. After that, I got a scholarship from UK, University of Southampton. That was the era where wireless communication, mobile phones, internet, everything that was booming. Like it was the beginning of 3G technology. And I enrolled in the university in a master's program since I was always interested in coding more than anything else. There I chose to work on channel estimation, channel coding, so coding for wireless communication and signal processing, filter theory. And that actually made the background for my PhD. My PhD supervisor, when I talked with him for the first time, he told me that we are going to work in machine learning. I heard that name for the first time. I told him that I don't know anything about machine learning. Later I realized that machine learning was nothing but adaptive filter theory. So it was just system identification, designing dynamic systems and everything. That is how I moved from electrical engineering to machine learning to AI and to big data analytics, which is generally now considered as a part of computer science, but my personal point of view is it's hardcore engineering. That's how I did my PhD from Bilkent University, Ankara, from 2013 to 2017.
Bilkent is a private university.
It's a private university in Turkey.
In Ankara, the capital.
Yeah, and it's one of the top 4 or 5 universities.
Okay.
10 years ago, when Turkey economy was booming and it was very much connected internationally, politically everything was going well. Yeah. It came very close to world top 100 university. Now it's not even, I think, in top 500.
Yeah. Between when you graduated with your master's and when you decided to go do your PhD?
Between that, so there were 4 years gap between that, from 2009 till 2013. I worked as a lecturer in another university in Abbottabad. Yeah, okay. And on 2nd May 2011 or 2012, I was in Abbottabad. So that specific area was just beside us.
Okay, gotcha.
So I saw the helicopters and everything.
Oh, really?
Yeah.
Okay. So we're talking about the CIA operation that happened back then.
Yeah.
Wow, that's incredible.
Yeah, so that was...
Because people might not know this was 2nd May. I didn't know it was 2nd May.
Yeah.
Wow, that's incredible.
So that was the university. I was teaching signal processing electronics.
Gotcha.
So digital electronics and communication.
Gotcha.
And during PhD, although I was more working towards AI and machine learning, that was the time when these big names were not yet that popular and people were not, like in research community, people would use more technical terms or research oriented terms, not like populist concepts or populist subjects. My first project during my PhD was also related to wireless communication, mobile phone communication, and the transportation system.
Got you. You graduated 2007-8, right?
Yeah.
What prompted you to say, I want to teach people, as opposed to, oh, I'm in Southampton, right? I want to get a job in London, let's say at a hedge fund who hired at the time anyone who knew statistics. Come join us, etc. What prompted you to say, I want to go back to Pakistan and I want to teach people?
The actual reason is a bit both. There was a time when I decided I would stop working and I would stop studying further.
Okay.
I want to go back home. Teaching was actually always my passion.
Yeah.
And that was what I actually was looking for. And since I was planning to do PhD, staying in academia would actually ease the path for me towards PhD. If it's in academia, there are benefits that we usually get. One is the teaching, that you inspire people, you teach people, and then you get their progress, so it gives you an inner satisfaction. But also you do more research and learn more new things, and in academia you always remain like a student. You always feel young.
That's right. So you always at the cusp. You're a little bit naive, right? You try things.
Yeah. So for example, even now, like most of the semesters, we teach a course that we have never taught before, and there are things that we even ourselves don't know about.
That's right.
And especially in this new era where everything is changing very rapidly, we don't rely on the conventional courses. It's always new courses. So data engineering, big data analytics, generative AI, large language models, these type of courses did not exist a few years ago. So then as a teacher, you'd have to learn that.
Got you.
Not just learn to understand, but learn how to teach. And how to deliver the message.
So at the time, so going back to Bilkin, what the first few years, I guess you took courses, etc. Eventually you had to do a PhD, a defense, etc., a dissertation, etc. So what's the thesis about?
My thesis focus was on, we called it adversarial learning.
Okay.
So learning in an environment, so machine learning in an environment which is not easy. And we focused on a problem where there is no linear relationship. There is a very complex relationship between the input and output. And even that relationship is not static, it's not stationary. It changes with time. And we took that problem because real life systems behave like that. A real life system don't have an abstract view like we would like to think of.
It's like
they are more complex.
Don't play a game of chess where the rules are the same.
Exactly.
It's even like a video game that you're playing, but even the video game maybe gets upgraded and it gets rebalanced and changed over time.
So that is why the title of my thesis was non-linear learning in an online setting for big data.
What part of it was adversarial?
There were high dimensionality. There was non-stationarity, and there was the size of the data, and there was a variety of applications. The first paper that I wrote, the title was universe. The focus word in the title was universal. So we wanted to build algorithms that are universally applicable to different problems under different settings. Then I moved directly to Singapore for a 1-year stint as a data scientist and as a research fellow, where I worked in a team of very competitive people. There were people from different backgrounds and different skill level. There were master students, brilliant undergrad students as well, and PhDs and professors. In PhD, I was working more on the algorithmic side. So during postdoc, I was working more on the applications of those algorithms, those methods, because that was the place where I found the real life problems where I worked on using the similar algorithms.
So just for background, a former campus of MIT, the Massachusetts Institute of Technology, that opened up in Singapore, that later on became
I don't know if it could be called a campus or not, but the university was called SUTD MIT.
SUT, so Singapore University of Technology and Design.
And there were lots of faculty exchanges between the two universities. The initial curriculum was designed by people at MIT. So if we call it a campus, that means the degrees awarding institute is MIT.
Got you.
So I don't think that was there.
But at least the research institute was there, and the intent of it, if I understand correctly, was to solve real problems for Singapore.
So that's what interests me the most at that time, that the focus was on developing products, not on individual technology. So the departments were not called electrical engineering, mechanical engineering, computer science. A department was called engineering product development.
Okay.
So there would be computer scientists, electrical engineers, environmental scientists, even social scientists
So
working
a bit more
together.
like the media lab at MIT is an example.
Exactly. And the labs were also like that. It was
Gotcha.
truly interdisciplinary.
And what did you work on?
One problem was about the predictive analytics of physical systems.
Okay.
So we worked on the predictive maintenance of hardware-based systems. So we had some devices, some big hardware. There was a device which was used to test PCBs, and there was some autonomous vehicles as well.
So this was the partnership you were mentioning earlier with HP.
Yeah, that was the HP one.
Do you know what is the link between HP and Singapore? That they have an R&D center? That they have folks that you work with PCB testing?
I don't know. I think there was a lab.
Okay.
It was called HP Keysight Lab.
Got you.
But I don't remember exactly. And
Okay.
it was R&D projects given to the university by the HP Singapore.
You had your chance to work on the hardware level side of the problem,
Yeah,
as well
so,
as the AI element.
So on the hardware side, I was actually collecting the data from the sensors, and then I was working on that data. So that is my link with the hardware at that time. I wasn't actually working with my hands on the hardware.
No, I got you.
Yeah, but the sensors were installed by somebody else,
Right.
and the data was coming to me, and I was working on that data.
Because for sensor data, there's a lot of people who would say themselves that they are data scientists. Oftentimes, the data might be, let's say, social media data or something that was generated digitally, and that they already have everything in one box. But with the lower level, to the sensors, a sensor itself can generate an infinite amount of data.
Yeah,
Like you have to pick and choose and transform.
And at times it's more diverse, it's more varied, because if on one side you have temperature sensor where the readings would be in Celsius or Kelvin or Fahrenheit, on the other side you have volume, on the other side you have pressure. So they have different scales, different standards, different measurements. So even processing and cleaning the data and putting that together into one table is a big task in itself.
Because they don't stop. They're not like teenagers texting. You think they don't stop, but that's a lot less than a sensor measuring temperature or volume or things like that.
This is what I usually say in my lectures, that when we talk about language, when we talk about natural language processing or large language models, when we talk about language is a medium of communication. So language is not necessarily a verbal language like English or Urdu or Punjabi. Images, videos, they are also language. The birds speak, animals, that is also language. The computers, when they interact with each other, they send packets, data. By reading the data, a computer sends or transmit over the internet, we can tell about the health of the network, we can tell about if there is any discrepancy, if there is, let's say, an intrusion or hacking or something or unauthorized access. So that is also a language.
Same where proteins are language, the DNA
exactly.
is language.
So when we talk about the sensors, that is the language of the machine.
Right.
So when we analyze sensor data, it has a lot of similarities with the natural language as well, because the main problem that we were solving in the natural language since almost 10 years very actively, and we had a huge breakthrough with the advent of transformers, because the natural language has a context and has a sequential kind of nature. So it's not individual words or individual letters that you combine. If there is a sentence written in one language, you translate word by word, it would lose its meaning.
That's right, yeah.
So that similar phenomena exist in the data generated by sensors, and that same phenomena exists in data generated by computer networks. If you translate a packet individually, they may mean something different, but if you combine them, and if you take into account the time and the event or the context of that packet, that would mean something different.
In the same way that in a sentence, the paper by Google was about how if you create these attention mechanisms that will capture the neighborhood where the sentence is, where the paragraph is, where the text is, where the book is, where the internet is.
And that is what
increasing the context
so as
or the attention.
One problem that we were working on during my PhD was using the network traffic as a language and language modeling. So making a language model for the network traffic. Traditionally, the network traffic analyzers or the intrusion detection systems, we used to call them signature-based detection. So for example, if there is certain specific type of packets or the number of packets or the IP or the MAC address or like signatures, we would look at them. So if that's suspicious, the intrusion detection system would flag that suspicious activity. And so there was no context in that. And because of that, network intrusion systems, especially after a rapid increase in the network traffic, like from terabytes to petabytes and zettabytes, the conventional systems stopped working. So probably it's like you had an antivirus system designed in, let's say, 1999, it won't work in 2005 or 2010 or 2020. So that's what we call signature-based system, because on one side, it would let go malicious traffic because it doesn't know its signature, it doesn't know that it's malicious. On the other side, it would stop genuine traffic because it didn't know that this kind of traffic, this kind of packet can also exist. So for example, if you design a system in, let's say, early 2000, there was not much traffic related to multimedia on the internet. There was no video streaming, there was no YouTube or Instagram. Mostly it was text, or mostly it was emails or IP calls, voice over IP. So that is why the network traffic also behaves like a language and it evolves like a language. So we needed an intrusion detection or analysis system very similar to natural language processing or language models.
How does this apply to the work that you did with the HDBs in Singapore around the power system?
For the HDB, like in the energy system, we wanted to make the devices more energy efficient, and the heating system, we record the data from the sensors. So like in the heating systems, in the pilot project that we did was there were 5 heat pumps, and conventionally they would start or they would turn when they are needed. So for example, if there is one heat pump needed, heat pump 1 would always be on.
Okay.
If it's not enough, then heat pump 2 would turn on. Then 3, then 4, then 5. And then similarly, if there is no increased load, then heat pump 5 would turn off first, then 4, then 3, then 2, then 1.
Got you.
And the problem with that was that heat pump 1 would always be on, so it would have a lot of wear and tear, but 5 would remain as good as new.
Right. Or sometimes even when you don't operate them,
yeah, so that's another problem.
Have other problems. Yeah.
So one thing, it was a fixed, like a logic-based system that was working, and that mostly how we operate things. Like air conditioning system, it used to be logic-based. If you set your AC on, let's say 25, so when the room temperature reaches 25, it would turn off, and when it increases, let's say goes to 28, it would turn on again. So with real-time monitoring of the environment, of the temperature, of water or air, instead of turning it on and off, which is also not very energy efficient, you can do it differentially. It would always remain on, but with different power settings as according to requirement.
Gotcha.
Or if it can be one device with multiple differential settings, or it could be multiple devices working as a cluster, and it can also be used on GPU clusters. Let's say you are building a large language model, you are training a large language model, and sometimes you need more memory, and sometimes you don't need that much memory. So the load would be distributed across different GPUs differentially. So it would make those GPUs or any systems more energy efficient and more productive as well.
Got you. So same idea. So the GPU or the heat pumps. And just to clarify here, from a purely operational standpoint, like heating, I assume this is for heating the water that they consume. Is that correct?
If I remember correctly, they were for heating the apartments, but since in Singapore,
it's never
no
so they're always
needed.
off.
Yeah, I don't know if it was because it was heat pumps, but probably it was for cooling, something like it could be for cooling.
Gotcha.
Because I didn't actually saw those devices. So it could be for cooling. It doesn't matter if it's cooling or heating. It's just playing with the temperature.
Yeah, because I wonder. I'm not sure. I'd love to know, but I don't think HDBs in Singapore have central cooling systems. But I'm pretty sure they do have some kind of central heating system.
Yeah.
So maybe it's about, I'm just conjecturing here, maybe in the morning when a lot of people take their showers, there's more demand for hot shower,
for heat,
things like that.
For water heating, there are central systems, but not for air heating.
Yeah, I'm guessing. I don't know. Did you go back to teaching after your stint in Singapore was over? And where did you go?
Yeah, actually it was over a bit prematurely. because I have a younger brother who is now working in Ireland in UC Dublin. At that time, he was doing his PhD and he got leukemia. He got blood cancer, and he was in China, and
for treatment.
Yeah, no, he was doing his PhD in China.
Okay.
And then his treatment was also started there.
Okay.
And since it was like far away from the family in any way, from parents and from siblings and everything, it eventually naturally became my responsibility to attend to him.
Yeah.
So that is why I had to take extraordinarily long leaves to attend to him, because it was a long procedure. It was almost active procedure within the hospital. It was 5 or 6 months, but then it was for the whole year.
The recovery is
So that is why I had to travel to China a few times, and then I went back to Pakistan.
What city in China was he at? What institute?
Nanjing.
So you traveled there, and I guess they were in Nanjing. The university was teaching in English. So he was doing his PhD in English in China at Nanjing University.
Yeah.
Wow, that's amazing. Is it called Nanjing University? Or
No, not Nanjing University, but his university was called Hohai University.
Hohai University.
It's a different one.
Very interesting.
Yeah. After his PhD, he worked in France for 1.5 years, and then now I think he's almost 2 or 3 years that he's in Ireland.
Got you. Also on the AI side of things, or
not his specialty is water treatment, water processing, water management, and climate. But he works on it from a data-driven perspective. So, climate prediction, irrigation management, like environment management, working on with the sensors, working on this data collected from sensors like rain sensors, weather stations, satellite data.
Got you. It's interesting because I'll have to introduce him to my friend. His name's Usman Khan.
Okay.
He's at AWS and he has a PhD from McGill, where I met him in Montreal. He's Pakistani, grew up in Islamabad.
Okay.
But did his undergrad at McGill in chemical engineering, I believe. And then he did his PhD in environmental engineering on water treatment. But specifically for the water resources of AWS data centers used for cooling. And this was actually our first sort of major project at bld.ai.
Okay, that's interesting.
Because at the time, we were not serving any major corporation. We got a shot thanks to him because of my personal relation. It's very hard to go pitch to, but he had a problem around water management, around planning tanks and trucks and etc. And weather and data center consumption and the topology of how all of the data centers are hooked up together, and traffic because those trucks need to go there, and the city and the uncertainty around cities. He spent some time around the world in different places. Actually, he was also at McKinsey & Company for a bit, I think. But I think he's back in Arlington or somewhere in DC area doing water work for So yeah, it'd be great to connect. Then you went back to the Harvard of Pakistan. Is that right?
Yeah. So there is an interesting thing. My background was always engineering. So I was an electrical engineer. I did my bachelor in electrical, master in electrical, PhD in electrical. And at that time, I didn't know how the world perceived these new fields of data science, big data, and AI. There was a position announced and I applied for it. When I went to the interview, the first question that the interview panel asked me, as an electrical engineer, why did I consider myself suitable to teach at a faculty of computer science? I didn't know it was faculty of computer science at that time, because I was applying as a teacher in data science and AI. I didn't know that it was part of computer science. So that is how I became a computer scientist. I still don't consider myself as a computer science guy, but that was actually the time when universities started realizing that this is the new nuclear energy, or this is the new science, or this is whatever you call it, the data science and the AI. And they were starting new programs. So first they started from masters, and then they trickled it down to a bachelor level. So I was the first person there to teach data science to students inducted for the data science degree program. After spending 1 year there, because I didn't like Islamabad much, this was my first time living in Islamabad, I moved to GIK because one of the reasons was that it was near to my hometown. And for them hiring me, the reason was that they were starting new programs in data science and AI. And there were not many people working in this area at that time. So like still, it's not easy to find, especially in Pakistan and probably all around the world, universities want to start degree programs where there is data science or AI in the title.
That's right.
So they don't want to call it computer science or engineering or something. They want to put that in the title so that it can attract students and they can build their reputation or revenue on that. On the other hand, there is a problem with this, that universities don't find the resources to teach those programs very easily. The human resources as teacher as well as the labs that are required, not in terms of the hardware that they can get into, but the resource, the people who understand those things. So for example, if I'm a university, I want to build a very good research center in AI, for which I need to develop a GPU cluster or an HPC or something. But for that, I need people who can understand those things, who can design the lab. So there is a gap still, and it's not decreasing, it's increasing. Universities in Pakistan especially, they know that if we increase the class size from 50 to 100, more people would be coming in and there would be more revenue would come in. To accommodate those people, they need labs and they need teachers. So on one side, there is more utility of the people who not just talk about AI and data science as a vibe, but who actually understand what it means and who can actually work on them. And when there are good people, the industry would hire them with much more perks and salary than the academia, the university could pay.
Yeah.
And so if we think about like the Jan LeCun, he's the chief scientist or something, and all others, big professors of AI data science from Stanford and Harvard, they are working with the industry now. But probably by their goodwill or something, that's not easy for everybody. And the universities, especially, they cannot afford to hire.
Oh no, for sure. He's not teaching for the money. None of them, and all of those.
And especially for the mid-tier people. So for example, if it's a person who did his master's in data science and he is practically very good at doing data science, university cannot afford to hire him or her. University cannot offer him or her the kind of money that the industry can pay.
Given everything that you know and all the students that you've taught, etc., you're a 9-year-old, a 10-year-old today. What's the best way to prepare?
I very strongly believe in STEM education. I'm a firm believer of teaching the kids mathematics and programming from a very early. This is a human problem that we are usually very resistant to change. We always like what our parents did or what our grandparents did and how they lived. But as time changes, so we have to update the curriculums, the schooling system, the education systems in general. For the kids, if they are given a choice, if they are given freedom, they can do wonders. They can work better than many experienced and knowledgeable people because they have the energy, they have the time, and they have the interest. They have a better view of the world than us. So for example, as compared to when I was 10 years old, my son who is 10 years old now, have a much better view of the technology, and he has a better opportunity to adopt technology and to learn technology. We didn't have internet, they have internet. We didn't have access to AI, they have access to AI.
I was at one of my parent-teacher discussion in Singapore. My kids are in local school in Singapore, and the director of the school, I think she's the youngest ever, but she was explaining to the parents that actually she recommends that don't have mobile phones and don't get exposed to technology in general in primary school. And people were whispering around me, I think every kid has a phone, every kid has an iPad.
If we can think about as a generic term as technology or specific AI, so not just kids, even us adults, there's lots of skepticism, lots of resistance to the adoption of technology in people. And so right now, instead of focusing on whether it's good or bad, we should focus on how to adapt and how to live in this new era. So banning things, stopping people from using things or stopping yourself from using something won't do you any good.
They'll do it anyway.
Yeah. So this, whether we like it or not, it is here and it's going to be here and it's going to be better and more powerful than this. The only thing that we could do is to be better at it, to be more educated about it. This is very similar to the argument about sex education, for example. There are people who think that children should not be exposed to any concept or any terminology about sex.
Like it doesn't exist.
Yeah. And the problem with that,
until the night of the wedding.
Yeah. The problem with that is that they are going to learn things in a wrong way from the wrong people anyway,
right,
because they are curious, they are going to be exposed. So it's better to teach them before they learn it the wrong way. The same case is with technology. If they consider the computer, their personal computer or a mobile phone, as a problem-solving device from a very young age, that would be their first idea about that device. If you don't do that, then they would consider that device as something that you could do, harass people online, scam people.
That's right. I think also things that are very addictive, that they will come across it.
Exactly.
Like YouTube Shorts. And if you try to completely shield them from it, first of all, they'll start in hiding, and then you'll catch them in the room like doom scrolling through TikTok. And even if you try to say no TikTok on the phone, no phone, no this, then it becomes a war. And that war erodes trust with the kids, etc.
And there's also with gaming, you can introduce them to gaming that are good for them or not as harmful as some games could be. Same with the sports, because whether parents want it or not, kids are going to love sports anyway. That's in their nature. They are outdoorsy. They want to always keep running. They have lots of energy. They want to use that energy somewhere. That energy could either be transferred to sports like football or cricket, or they can become fans of MMA.
My kids do Brazilian Jiu-Jitsu and ballet. They do both.
So especially that is also the reason that these kinds of sports are standardized and popularized, like Jiu-Jitsu or Kung Fu, or because it is something that you could, like a kid would fight with other kids, harm him or herself or other people. You could channel that energy in a positive way. Same energy, same passion, same sentiment, but now used in a positive way. So convert that into football or karate or judo or something like that.
One of the big positive aspects to me of Brazilian Jiu-Jitsu is the fact that every class they spar. And usually the professor doesn't make one kid win every fight, right? So the professor wants them to be 50-50. So they learn to lose, and they learn to and swallow their ego every single day that they go. In my case, let's say they go 4 or 5 times a week. So they do a lot. Kind of crushes your ego. Even when you go to medals, they were actually in Kuala Lumpur for IBJJF. And neither of them got gold medals. They're good. They could have gotten gold medals. They were edged. Like the final match was very tough, and it was even as a parent, it was tough emotionally because the judge went one way and then reversed the decision, and it was so emotional.
I actually saw that firsthand. My kids are very much into football. So when they are playing properly, like in a proper time and with teams and jerseys and everything, and they are very calm and composed. They fight within the game, then outside they are friends. But whenever that is stopped, and it did happen a few times. Last time the coach went to another place for a better salary. Then they started playing in the streets. They started fighting with each other, and they started damaging people's property. That is why being hard on kids, giving them hard time, that is not a solution. It is going to bring more harm than benefit. But instead of channeling that energy into something positive of similar nature, which looks very similar. So like using a computer all night and losing sleep for it, watching say TikTok and losing sleep for it, but doing something productive looks very similar, but they have very different results, very different outcomes.
As a young kid, let's embrace technology. Let's embrace sports. Let's embrace adversity. Let's introduce them to this so that they understand the elements, right? Losing, winning, getting addicted, recovering from addiction, all of those things, and make it a learning journey for them. And I think that's probably advice for a lot of parents. A lot of parents is get into it. The sooner you expose your kids to STEM, to math, to programming, the better. I personally, if I can plug my shameless plugs, or they're not actually shameless plugs because I'm not affiliated with them, I love to get my kids into MIT Scratch, but soon I want to get them into Code Forces for competitive programming. I also really appreciate the value of this app called Art of Problem Solving, which is a US company that has sent numerous kids to...
my kids are also working on that.
Oh, there you go. So there's Beast Academy when they're young. My daughter is 6, so she does it. As the kids get older, they finish Beast Academy and then they move to the next level. And that's all about math Olympiads. But computer science and programming and math is a big overlap. Right? It's obviously math is the language, and the competitive programming is about managing your memory and managing the time and managing the compute power that you have to solve a problem, ultimately with algorithms that are mathematical. It's language. So if we go a little bit older, right? Say that I'm a 16, 17, 18, 19-year-old finishing up my high school looking to go to university, what is your advice there? What can they do to make a difference and to embrace? Maybe they don't know coding yet, or maybe they do. What's your advice?
There is one very important thing. University education is not just the education. It's not just the courses that we teach or we study. We can learn things from many different sources before university, during university, outside university, and even after university. It's about an experience, about a lifestyle. It's how we get the problem solving attitude. So for example, if we have a 4-year or 3-year degree, if we think about the courses that we study, just those courses, it shouldn't take 3 or 4 years. They can be done in even 2 years or maybe even in 1 year. And that's how we do it when you grow older and older. For example, if you are doing masters, you do many more complex concepts and topics and courses in 1 year. And when you are in industry, when you are working, you most of the times you learn to solve a specific problem or a specific subject even in one night.
Yeah.
Because you exactly know what you need.
Yeah.
So you go straight for that.
You've learned how to learn fast and to prioritize.
Yeah. So the university experience, those 3 or 4 years, actually prepares you for the learning after that. The way you said, learn to learn, or learn how to solve a problem. So in that case, there is this issue, which is what we call trend. Sometimes people call it scope, like this computer science has no scope or it has all the scope.
Right.
Electrical engineering has no scope or it has all the scope, and suddenly everybody wants to do electrical engineering or everybody wants to do computer science. So that becomes like a race. If other people are doing it, I should also do the same. That is one thing that I think people should not be very concerned about. The purpose of education or the purpose of any kind of work to solve real world problems around you, whether it's engineering, whether it's medicine, whether it's computer science or social sciences even, everybody is working on some aspect of life, our own life and the life around us. We want to save ourselves, we want to be better for ourselves or for our family or for our community or for the world or for, let's say, the animals or the birds or the trees. And to solve those problems, we need to study those domains. Everybody is different, everybody is interested. There are people needed in every field. And now the world is coming very close again, and instead of thinking of these fields, these domains as something which are very different from each other, which are not related at all, this is what we call life or phenomena of life ontology. Mm-hmm. Is it ontology? Okay, so it's not clustered, it's not discrete, it's more like a continuum. There is no barrier, there is no hard stop where one subject ends and the other one starts. They're more closely related to each other, and it's the transition from one domain to another domain is continuous. And although AI and data science, they're very important, instead of focusing on few people or more people doing just AI and data science, we should focus more on people working on different domains, learning different domains, but with data science and AI be part of that. It is like the new language. As you may think, everybody needs to learn language. Whether they become a scientist, doctor or an engineer, they need to study language, right? Because that's how they can read books, they can learn about things. Similar to that, everybody needs to understand AI and data science, and they can use it in their own domain.
Back in the days, everybody needs to be able to know how to go to the library and pick a book.
Exactly.
So everybody needs to go to Google and learn how to search something.
Yeah.
Now everybody needs to learn to leverage, to prompt engineer these AI systems,
yes.
retrieve knowledge.
Even right now, let's say if you want to hire an AI expert or a data scientist for a particular problem, let's say that problem is related to the energy conservation, energy consumption, and there are two people in competition. One is a highly qualified computer scientist and expert in data science and AI, and know very little about the energy or the electrical systems or any kind of energy systems. Yep. On the other hand, you have a person who is an engineer, or who is an energy scientist or whatever you may call it, who knows the concept of energy, the consumption and everything. He is an expert in that and knows a little bit about data science and AI.
That's right. Yeah.
That second person would solve the problem more efficiently and in a better way. So domain knowledge is still needed, would still be needed, always would be needed, and more than ever we need people working in hardcore science fields, so physics, mathematics, and on the third, I would say engine. So they are as important as languages or as ethics or as social sciences.
And more money is getting deployed also against people who have this domain knowledge and who can combine this cross-disciplinary approach.
And if now is the time, if you are going to the segment that you talked about was, what do I want? Right now, there are people who think that AI is more powerful and more, like ubiquitous and everywhere than we had expected. AI is doing things that most people didn't even expect it to. And then on the other side, there are people who are actually working in AI and they are more frustrated with how bad AI is right now, how not enough AI is right now.
Yeah, exactly.
For example, I'm not from a medical or health sciences background, so I may claim that AI can replace doctors, but a doctor who is actually working in a clinic and he's using an AI system,
a real expert, is frustrated with it.
He or she would be frustrated that why is it not working, and it actually promised me that it would save my time, but it is now actually investing my time.
Exactly. Field experts don't feel threatened by AI. They're welcoming it, and then they're like, oh, this is falling flat on its face.
Yeah. So if there are people who thinks that AI right now is not what people think it is, and it's not enough, and it should be much better, it's exponentially faster than how it was like 10 or 20 years ago. But it's still not ideal. A person working in the medical field, he or she wants to use AI, but he doesn't know anything about AI.
That's right,
If we sit together, I do not speak his or her language. He or she doesn't speak my language.
That's right.
We don't understand each other. So there is a big communication gap. That is why the solutions that are being developed are not perfect. They have limitations. For example, if I take the universal or the public AI models that we have right now, like OpenAI, GPTs,
the OSS one.
The Meta's Llama and the Google's Lambda and Gemini, the core models are not developed for specific applications. They are more targeted as universal problem solvers. So that is why there would definitely be areas where these models would suffer, and then we would say that Meta's Llama is working better than Gemini, or on some other kinds of problem, Gemini is working better than OpenAI's GPT. People would have their favorites and everything. Now is the time that we should work more on interdisciplinary development of AI from the perspective of real life problems. If you ask me what I would like to build it as BYOAI, build your own AI.
Build your own AI,
Okay, so build your own AI could be a platform where people can have access to different models and they have access to different resources, could be hosted somewhere, and there is another AI model on the front which would actually take the user's input and translate that into logic that would select more optimal combinations of different models or train a new model.
So like an ensemble approach.
Exactly.
It's actually similar to what our solution partner have done. They were a lot of former, I think 2 top 20 Kaggle competitors when Kaggle just launched, and they recruited the #1 ranked guy who was a French guy living here in Singapore.
Okay.
And they figured, hey, we want to solve the auto ML problem, because they realized they kept on winning contests and doing very well, and it's in part because they had a lot of scripts that would do the right model selection, hyperparameterization, and so on and so forth, feature engineering, and they figured, hey, there's a business opportunity here.
Right now, almost every big company which has a public face has to communicate with customers, use chatbots, what do you call customer support or customers interaction.
Yeah, the first line, the level 1,
Yeah. So for example, Shopee, Lazada, Amazon,
all of them.
The approach till now is that if I want to communicate with my customers through a chatbot, I would just hire somebody or buy a product from somebody and install it. Since I would pay a lot of money for that product, I won't replace it soon. Those chatbots, even for some very sophisticated organization, they are very poor. Most of them are just knowledge based. There is
they're toothless. They don't perform any functions.
They give you some options and you'd have to select from it. Yesterday, I think it's a government organization about the highways, the tolls and everything. It's called Plus. I visited its website. I wanted to know about the tolls and where should I enter the highway and where should I exit. So I started communicating with the chatbot. The first question it asked me was, what's your entry point? So I wrote the entry point, but there was just one letter spelling mistake and it didn't consider it as a valid input because it was just able to look up from a list, nothing more. So if it wasn't in the list, there are like 50 places in the list.
A human would have fixed it for you.
Yeah, that is why. So there was no spell check, there was no spell correction, there is nothing. It was just a table that it was looking from and fetching the results and displaying it. So we are just, in those chatbots, we are just communicating with a web server. There is no AI model there. And the reason for that is that once they build the chatbot, they implement it, they cannot replace it every day. Their chatbot, their agent, whether it's AI or not, would definitely have to be static. It won't be dynamic. And now we have the technology to make chatbots or to make AI dynamic. We have RAG. We have fine-tuning. Fine-tuning is expensive. It cannot be done on the client side. It cannot be done on the product side, but RAG can be used. So if we have something like when a company gets a chatbot or develop their own, the chatbot technology is updated. So it's not the old model. So for example, the Meta's own chatbot, which is in WhatsApp, Facebook, it is always updated when Meta launches a new model for the Llama series. They start with Llama and Llama 2. Llama and Llama 2 were different in architecture, but after Llama 2 it's just the retraining and fine-tuning. The difference between Llama 2 and Llama 3 is they've been trained on different data, and Llama 3 performs better than Llama 2. If we can do that on the production side, that each company who uses a chatbot can have a chatbot which is dynamic, which not only adapts to the new technology development but also adapts to the new knowledge. It would be truly useful and a more transition from the development to the production and to the usage of technology.
And how do you see this coming together? Are you thinking of this as like a startup that...
Yeah, I wanted to mention. Okay, so the big guns in AI, OpenAI, Meta and Google, they usually roll out a new model, an updated model after some time, after a year or after 6 months.
3 to 6.
But on the other hand, we have open source community where new models are coming every day. And when a mainstream model is launched, on the next day you would see hundreds of different better versions of it on Hugging Face.
We had a bit of a technical failure because our camera was overheating. It is so hot in Malaysia that our Japanese equipment just can't take it. And then we got into a super interesting discussion around how educational systems came about as a way to subjugate for a kingdom to invade another one, to brainwash the population into their own way of thinking.
That is why I have a problem with parenthood, like how parents usually consider themselves or feel entitled. Usually parents would put their kids into school or into discipline so that they do not question their methods. That's why we have this concept of respect your elders, respect your parents, listen to your parents. Your parents always wants the best for you. To that, I usually say that our children, our kids are our responsibility, but they are not our property.
They're not our property,
That means we have to provide for them, we have to take care of them, but we have no right to curb their freedom and to stop them from thinking on their own or making their own mistakes and learning from those mistakes.
Because it's a missed opportunity to leverage their creativity.
Yeah, exactly. So that is why I personally believe that although it is changing with time, parenthood is not so regressive now as it was like 50 years ago or 100 years ago. But still, it's my opinion that we should give our kids more freedom and more exposure to the world, to the problems, to the goods and to the bads.
So how does that tie back into this idea, right? The startup that you were discussing.
I was just thinking about this. You mentioned about the air conditioning system.
Right.
We have a lots of problems with our engineering as well. For example, in Malaysia, in most of the territories, regions, we don't have a heat problem. We have a humidity problem. For example, 25 degrees in a dry environment, in a dry region, it's comfortable. It's even more than comfortable.
It's almost ideal.
Pleasant.
Yeah, exactly.
Yeah. But in Malaysia, 25 degrees feel very hot.
Yeah.
The air conditioning system that I use here, they all have the cooling system and focus on the cooling system instead of so for example, if you keep your AC on, dry setting is there something or like that, that is enough. That works well, much better than if you turn the cooling
comfort level.
Yeah, but if you take the same air conditioner to, let's say, UAE or Saudi Arab or Syria, it would not.
Where it's dry naturally.
Yeah, but very hot, extremely hot.
Yeah, like 40 Celsius, 45. Yeah.
So that air conditioning system, because they are mostly made not locally, but by major companies around the world like Japan or China or German. There are a few big names who made them. They usually do one design. The design changes with time, but not with space.
That's right. Yeah.
So same thing with AI is that every problem, every domain, every challenge could be different than the others. So instead of focusing on whether an AI model can solve a mathematical problem or not, and doing a comparison of all the AI models based on one specific kind of problems, each model can solve a different kind of problems with different accuracy and efficiency, and we can use that model for that specific purpose. And we should focus more on individuality of the problems rather than making one solution, one cannon that kills all or something like that.
An analogy that I've used a number of times that maybe I don't hear it echo enough, but it's that there's a race towards artificial superintelligence or artificial general intelligence, but bigger models doesn't mean smarter intelligence.
Exactly.
Like an elephant's brain is huge, whereas an eagle brain is tiny, but the eagle can see better than the elephant because its task is to catch.
And it needs to see better than the elephant.
1,000 meters down.
And the elephant doesn't need to see.
Exactly. Yeah.
Especially because of that, we have the AI, which should be democratizing, which should bring more equality in the society. If our focus is as it is right now, it is going to bring more disparity, you can call it, because right now when we talk about language models, if we compare it with the history, with the previous ones, not what we expect in the future, they're performing very well, but on certain languages only. So for example,
cultures.
If you use an AI model to translate something from one language to another language, if both those two languages are highly resourced digitally, then the model would perform very well. So when we talk about multimodal AI, we mean the AI is not just for text generation.
Vision, hearing, scent, like our senses.
Yeah, exactly. Still, most of the focus right now is on text and images. Very less focus on speech. And it's not that it's not or people don't want to do it. One of the reasons is also because it's much more challenging than images and text. And it is more important than images and text in the sense of communication, because speech is the most used form of communication between humans. When you talk to somebody, most of the time you would speak or you would listen.
There's facial expressions, there's emotions.
Yeah. For example, if you write a text, it has a meaning. If you don't change the words and letters, that meaning won't change much. The words carry the meaning, and the sequence of words carry the meaning, or the context carry the meaning. But in speech, it's not just the words or the positioning of the word, the context. It's also the variations in
intonations, aggression.
Same sentence spoken differently would mean a different thing. Also, in speech, we need much more high fidelity than images or text. So for example, if you create an image which is not very high resolution, if you want to use an image to identify a person, let's say it's a biometric device which identifies people by their faces. Sometimes if it's of low quality, it would still work. But if it's sound, if it's speech, then a variation in the quality on the downside would make a lot of difference. If there are two people teaching, same subject, same content, even same sentence, everything same, but their voice quality, their diction, and their way of speaking is different, it can directly translate to the understanding by the student. If I speak more than 10 minutes, probably a student would get bored and they won't want to listen to me again. There could be another person who speak in a better way, in a more articulate way, and the students would like to listen to him or her, and they would learn more. So speech generation through AI is much more challenging. Okay, that was a side note. I'm coming back to the problem with the example that you gave about elephant and eagle. So all of language models have this issue, but especially with speech. speech synthesis models. For example, last time I checked the state-of-the-art models, the one I used, probably they are better now, was called Seamless, and it's developed at Meta. The performance of the speech synthesis model is usually evaluated by its word error rate. In 100 words, how many words it can produce correctly or wrongly. So with good resourced languages in the digital domain, the word error rate is as good as 3 or 5 or 6 in 100 words. And in text, it is not a good performance, but in speech it's a very good performance. But in scarcely resourced languages, like the languages of Africa or South Asia or other far-flung areas which are scarcely resourced, there are not many people who speak those languages. There are many more people, probably in hundreds of millions people who speak those languages.
In Nigeria.
But those languages are scarce digitally. In the digital domain, there are not many websites where the language is, let's say, Nigerian or African or Pashto or Punjabi. Since there are scarce in the digital domain, there is not enough data to train model that would work well for those languages. So the model that I was talking about has a word error rate around 40, 45 and 50 in those languages. That is the state-of-the-art model, which is still multiple times better than the previous speech generation models.
But I guess we're losing diversity of culture.
Exactly. So that is why right now we need to focus more on the domains which are otherwise easily be ignored, but still they are more important.
Thank you, Rob, for time, but it was really amazing. I'd love to keep going for hours. I look forward to learning from you. I look forward for us to work together, and I look forward to us to educate many people on AI around the world. Thank you so much. Until next time.